Hi, I'm Sean Keef. I run sales enablement for Skybox Security. Here's a demonstration video on attack simulation from vulnerability control. This slide is a great place to start explaining attack simulation. It can sometimes be a confusing subject as there are multiple sets of data being brought together. When going through the demo, signpost often. When presenting this slide, I start out by establishing that we have a network model that accurately represents the customer's network and accurately understands how traffic can move between any 2 points on the network. Next, we bring in vulnerabilities. These are typically brought in via a vulnerability scanner, and of course, they have assets associated with them. So now we have a network model with assets and vulnerabilities. Next, we'll model some threat origins. These are virtual bad guys that represent common possible attack vectors. Ingress points and workstation networks are common threat origins. So now we have a network model populated with network devices, classified assets, vulnerabilities, and threat origins. Lastly, we'll run the attack simulation task to prioritize the vulnerabilities. This is the same progression we're going to show in the product. Let's see how this looks in vulnerability control. Our story starts with the network model. We've imported layer 3 device configurations and routing table data and ensured that the network model accurately represents the organization's network. If a path analysis demo hasn't been given yet, I would suggest doing one now. Please see the video on path analysis for more details. Next, we'll look at vulnerabilities, starting with Skybox's Vulnerability Dictionary. When we talk about vulnerabilities in Skybox, we talk about them either as definitions, vulnerabilities that exist in the world, or occurrences, vulnerabilities that exist on a specific host in the organization's environment. Here we're looking at definitions via the Skybox Vulnerability Dictionary. This is a threat feed that is compiled and managed by a specialized team within Skybox. Over 20 different sources of vulnerability data are monitored, correlated, and enhanced on a daily basis. Once that new day's data has been managed, it's sent to our customers so they always have the latest data on the latest vulnerabilities. Let's look at some of the elements of this data. We'll start with the CVSS tab. If the original data source doesn't include CVSS data, the Skybox team will add it. We're currently using CVSS version 3. The impact ratings of confidentiality, integrity, and availability are used with the same parameters on assets to determine an impact score, or an understanding of how bad it is that a specific vulnerability is on a specific host. Here we see a vulnerability with a complete impact on availability, but no impact for integrity or confidentiality. Next, let's look at the Affected Platforms tab. Skybox understands what application version or OS patch level a vulnerability is applicable to and which version fixes it. We use this data in conjunction with an organization's asset data to discover vulnerabilities using our vulnerability detector feature. Be sure to check out the video on vulnerability detector. Lastly, the Solutions tab. Here we see the available upgrades, patches, fixes, and IPS signatures that can be applied to a vulnerability to remediate or mitigate it. From here, let's move over to vulnerability occurrences. Vulnerability occurrences are vulnerabilities as discovered by a discovery method like an active scanner or vulnerability detector. They are vulnerabilities that exist on specific assets within the organization's environment. Here's a group of vulnerabilities that were discovered by Qualys, as we can see under the discovery method. Notice how these vulnerabilities, even though they were discovered by Qualys, have the same types of data that are found in our vulnerability dictionary. This data is overlaid from the dictionary onto found vulnerabilities to provide additional information for the vulnerability and to allow it to be prioritized. Vulnerabilities are typically addressed and remediated based on their severity. Here we can see that we start off with about 7,000 vulnerabilities, and about 3,500 of these are critical. Most organizations will start working on those critical vulnerabilities, and as they're remediating them, more critical vulnerabilities will be found. This causes a constant churn of the critical vulnerabilities, and typically results in high severity and lower vulnerabilities not being addressed. Risk stays flat as high-risk vulnerabilities are missed, and time is spent remediating lower-risk vulnerabilities instead. With attack simulation, we'll see a different way to prioritize those vulnerabilities. The next thing we'll do is look at the assets from those vulnerabilities and look at how we can categorize them. To categorize the assets, we'll use the Business Units and Asset Groups section in the Model tab. Here we can see a hierarchical structure using both a geographical and a business unit structure. The business asset groups hold hosts or assets. They can be populated either statically or dynamically. If we click on a business asset group, select Properties, and then choose the Business Impacts tab, we have the ability to choose what kind of damage would occur to the organization if a vulnerability exploit caused a loss of confidentiality, integrity, or availability on the asset. When we put this data together with our understanding of what happens when a specific vulnerability is exploited, we have a very solid understanding of the impact of a specific asset having a specific vulnerability on it. Lastly, let's configure our threat origins. Threat origins are the virtual bad guys of the system. They are relatively simple constructs consisting mostly of a location and attacker skill level. Typically, they will be modeled on ingress points as well as on the networks with servers and workstations. This is to understand the possible impact of a compromised workstation or server. Once these are created, all the pieces are in place. We have a good network model with network devices, classified assets, vulnerabilities, and threat origins. Now we just need to run attack simulation and see the results. In Operational Console, we find the Analysis Exposure task. This is the task that calculates exposure and risk scores via attack simulation. Let's go back to Vulnerability Control and see the results. The result is a list of vulnerabilities ranked by risk. Notice the exposure, direct and indirect. When an attack simulation runs, if it finds an exploitable vulnerability that gives full user or root access, it runs the simulation again from that host. This allows Skybox to find indirectly exposed vulnerabilities, the kind that are exploitable via a pivot or stair-step attack. Each time a directly exploitable vulnerability can be used to exploit another host, the risk score goes up for the original vulnerability. This will put the directly exploitable vulnerabilities usable in a pivot attack at the top of the list. You'll want to remediate those first. Lastly, we have Horizon. Vulnerability exposure, the output of attack simulation from vulnerability control, is one of the indicators of exposure that is shown in Horizon. It helps to complete the attack surface picture of an organization. So in summary, attack simulation is a powerful engine that's one of the ways to prioritize vulnerabilities in vulnerability control. It produces actionable data in the form of a prioritized list of vulnerabilities that is excellent in pointing remediation teams in the right direction. Thanks for watching this video on attack simulation from vulnerability control. Please visit our website for additional videos and resources.